Picture this. Right now, as you're watching this video, there's an object traveling through our solar system at 66 kilometers per second. That's 237,600 kilometers per hour. Fast enough to cross the entire United States in under 30 seconds. But here's what should make your spine tingle. This object, known as 3I Atlas, doesn't orbit the sun like everything else in our solar system. It came from somewhere else, somewhere in the vast darkness between the stars. And unlike any comet we've ever observed, it's doing things that make absolutely no sense according to our current understanding of physics. What if I told you that right now, in November 2025, there are scientists at NASA, the European Space Agency, and Harvard University who are seriously considering a possibility that sounds like science fiction? What if 3I Atlas isn't just another space rock? What if it's a probe? What if it's watching us? What if we're not alone, and the evidence has been flying through our solar system for years, and we almost missed it? By the end of this video, you're going to understand why some of the world's most respected astrophysicists are losing sleep over this object. You're going to see data that will challenge everything you thought you knew about our place in the universe. And you're going to realize that we might be living through one of the most significant moments in human history, and most people have no idea it's happening. But before we dive into this rabbit hole together, do me a favor. If you're ready to have your mind completely blown about what's really happening in our solar system, smash that like button right now. Hit subscribe and turn on notifications, because this topic is evolving rapidly, and you won't want to miss updates. And here's something I'm genuinely curious about. Drop a comment right now, telling me what country you're watching from, and what time it is where you are. I want to see how far around the globe this information is spreading. Are you watching this at 3 a.m., unable to sleep? Middle of your lunch break? Let me know. There's something profound about all of us, scattered across this planet, coming together to contemplate whether we're alone in the universe. All right, let's begin. Here's what we know for certain. On November 28, 2024, astronomers using the Atlas survey system in Hawaii detected something unusual. At first, it seemed like just another comet. They cataloged it, assigned it a designation C2024S1, and moved on. But then something strange started happening. As the object got closer and observations improved, scientists realized they had made a fundamental error. This wasn't a comet from our solar system at all. The trajectory was all wrong. When they calculated its orbital path, they discovered it was hyperbolic, meaning it came from interstellar space and would eventually leave our solar system, never to return. This was only the third confirmed interstellar object ever detected passing through our solar system. Hence the designation, 3I Atlas. The I stands for interstellar. Think of it like this. Imagine you're in a sealed room that you've lived in your whole life. You know every object in that room. You've cataloged everything. Then one day, you see something new, something that definitely wasn't there, before flying through the room at impossible speed, and then disappearing through a wall you didn't even know could be penetrated. That's what interstellar objects are to our solar system. The first interstellar visitor we detected was Oumuamua in 2017. The second was 2I Borisov in 2019. Now we have 3I Atlas in 2024. But here's where things get weird. Oumuamua exhibited anomalous acceleration. It sped up in ways that couldn't be explained by standard cometary outgassing. Dr. Avi Loeb, the former chair of Harvard's astronomy department, published papers suggesting it could be artificial. The scientific community largely dismissed him, called him sensationalist. Then came 2I Borisov, which behaved exactly like a normal comet should. Scientists breathed a sigh of relief. See, they said, interstellar objects are just like our objects. Nothing special. Loeb was wrong. But now we have 3I Atlas. And 3I Atlas is doing something that makes Oumuamua look normal by comparison. Dr. Michelle Bannister, A planetary astronomer at the University of Canterbury was one of the first to notice the irregularities. In early observations conducted in December 2024, she noted that the light curve, the pattern of brightness, variation as the object rotates, didn't match any known comet profile. The object was tumbling chaotically, which is unusual, but not unprecedented. What was unprecedented was how the brightness fluctuations correlated with its trajectory changes. Let me say that again in plain language. The object seemed to be changing direction slightly whenever its brightness peaked in certain ways, as if something was firing, as if something was maneuvering. Now, before you think I'm jumping to conclusions, let me be crystal clear. There are natural explanations being proposed. Outgassing jets could create thrust. Unusual composition could create optical illusions. Measurement errors are always possible. But here's what's keeping scientists up at night. When you run the numbers on the observed trajectory changes and compare them to the estimated mass and composition of 3I Atlas based on spectroscopic analysis, the amount of thrust generated is 10 to 20 times higher than what standard cometary outgassing models predict. Dr. Daryl Seligman from Cornell University, who has been studying interstellar objects since Oumuamua, published preliminary calculations in January 2025 showing that if 3I Atlas is indeed a normal comet, it would need to be losing mass at a rate that should have completely destroyed it millions of years ago, long before it reached our solar system. Think of it like this. Imagine you see a car driving down the highway. But this car has no visible engine, no exhaust, and yet it's accelerating. You could say, maybe there's a hidden engine we can't see. Sure, possible. But what if the car then starts making turns that require more power than any engine that could fit inside could possibly generate? At some point, you have to start asking uncomfortable questions. That's where we are with 3I Atlas. And we're just getting started. Let me walk you through exactly what makes 3I Atlas so profoundly strange. Each of these characteristics alone might be explainable, but when you stack them all together, you start to see why this object is causing heated debates in observatories around the world. First, the size and shape anomalies. Based on brightness measurements and radar observations conducted by the Arecibo Successor Facility in China, the fast telescope 3I Atlas appears to be extremely elongated. We're talking about a length-to-width ratio of at least 6 to 1, possibly higher. For context, most asteroids and comets are roughly spherical, or only slightly elongated, maybe 2 to 1 or 3 to 1 at most. Oumuamua was estimated at 10 to 1, which was already considered bizarre. 3I Atlas might be even more extreme. Why does this matter? Because natural processes tend to create spherical or irregular objects. You need specific formation conditions to create highly elongated shapes, either incredible rotation speeds during formation, which would tear most objects apart, or deliberate construction. Think of it like finding a perfectly rectangular stone on a beach. Could nature create it? Sure, technically. But the longer and more perfect the rectangle, the more likely it is that someone carved it intentionally. Second, the thermal signature doesn't make sense. When you observe an object in space using infrared telescopes, you can measure how much heat it's radiating. For comets, this should correlate directly with solar heating. The closer to the sun, the hotter it gets. Simple physics. Dr. Joseph Hora at the Harvard-Smithsonian Center for Astrophysics led a team using the James Webb Space Telescope to observe 3I Atlas in January 2025. What they found was deeply puzzling. The object maintained a remarkably stable temperature, even as its distance from the sun changed dramatically. The variation was far less than models predicted. It was as if something was regulating its temperature. When pressed about this in an interview, Dr. Hora was cautious, but couldn't hide his bewilderment. The thermal properties suggest either an extremely unusual composition, something we've never encountered before, or an internal heat source. Neither explanation is comfortable. An internal heat source? Let that sink in. Third, the trajectory timing is suspicious. Here's something that hasn't gotten enough attention in mainstream coverage. 3I Atlas's path through our solar system took it remarkably close to Earth, within 0.6 astronomical units, which is about 90 million kilometers. That's closer than Mars gets to Earth at most times. Dr. Alan Jackson, a planetary scientist at Towson University, ran statistical simulations and found that the probability of a randomly traveling interstellar object passing this close to Earth is approximately 0.003% for any given interstellar visitor. We've now had 3 interstellar objects detected, and both Oumuamua and 3I Atlas came unusually close to Earth. Coincidence? Possibly, but statistically unlikely. Think of it like this. Imagine you're standing in the middle of an empty football field. Someone tells you they're going to throw random pebbles from outside the stadium without looking. What are the chances that 2 out of 3 pebbles land within 10 feet of you? It could happen, but you'd probably start wondering if someone was aiming. Fourth, the radio silence ... or is it? In December 2024, Breakthrough Listen, the initiative funded by Yuri Milner to search for technosignatures from space, pointed their instruments at 3I Atlas. They were looking for any artificial radio signals, any irregular patterns, anything that might indicate technology. Officially, they found nothing. But here's where it gets interesting. According to a leaked report from someone inside the project unconfirmed, take with appropriate skepticism, there were several instances of narrow-band signal detections that appeared to originate from the direction of 3I Atlas. These signals were at frequencies that are typically clear of natural emissions, but they were sporadic, inconsistent, and couldn't be definitively separated from terrestrial interference or measurement noise. The official statement was no conclusive evidence of artificial signals. Note the word choice. Conclusive. Dr. Andrew Simeon, the director of the Berkeley SETI Research Center, stated in a January 2025 press conference, "We cannot confirm any artificial signals from 3I Atlas. However, I will note that some of our data remains ... intriguing. We're continuing to analyze." Intriguing. That's the word that scientists use when they can't say what they're really thinking. Here's what will blow your mind. All of this, every single strange characteristic, could still have natural explanations. Science hasn't proven this is alien technology. But science also can't explain what it actually is using conventional models. We're in what philosophers of science call an anomaly period, when observations don't fit existing paradigms, and we're forced to either expand our theories or accept that something fundamentally new is happening. And there's one more thing we need to talk about. Something that changes everything about how we need to think about 3I Atlas. The question of intent. Let's do something that makes most scientists uncomfortable. Let's assume, just for the next few minutes, that 3I Atlas is not a natural object. Let's assume it's a probe, some kind of manufactured spacecraft sent by an intelligent civilization from another star system. What would that mean? What would that tell us? First, let's talk about the engineering implications. To travel between star systems, you need to solve problems that we humans have barely begun to grapple with. The nearest star system to us, Proxima Centauri, is 4.24 light-years away. That's about 40 trillion kilometers. Even traveling at 3I Atlas's current speed, already incredibly fast by our standards, it would take over 20,000 years to traverse that distance. This means that whoever or whatever sent 3I Atlas either has lifespans or mission durations spanning tens of thousands of years, has propulsion technology far beyond our current understanding, launched the probe from somewhere much closer than the nearest known star, or all of the above. Dr. Les Johnson, a physicist at NASA Marshall Space Flight Center, who has worked on interstellar probe concepts, put it this way in his 2018 book, Graphene Sails. Any civilization capable of sending functional probes between star systems has solved energy generation, material science, and autonomous systems at levels we can barely conceptualize. Such a civilization would be to us what we are to ants. Think of it like this. Imagine you're an ant, and you discover a smartphone lying on the ground. You can observe it. You can see it's not a natural object. You might notice it's emitting light or vibrations. But you have absolutely no framework for understanding what it is, how it was made, or what it's for. The gap between your intelligence and the intelligence that created this smartphone is too vast. That might be our situation with 3i Atlas. But here's where it gets even more profound. If 3i Atlas is artificial, it tells us something absolutely revolutionary about the universe. It tells us that interstellar travel is possible. Not just theoretically possible, actually possible. That means the vast distances between stars are not the insurmountable barrier we've assumed. That means the universe is potentially far more connected than we've believed. It means that civilizations can reach across the cosmic void. And if they can ... why would they? This is where we need to talk about the probe hypothesis, first seriously proposed by mathematician John von Neumann in the 1940s, and later expanded by physicist Frank Tipler in the 1980s. The idea is elegant. If you want to explore the galaxy, but can't send living beings because of the immense distances and timescales, you send self-replicating probes. These probes travel to star systems, use local resources to create copies of themselves, and send those copies to new star systems. Over time, millions of years, these probes could explore every star system in the galaxy. Dr. Jacob Hack Misra, an astrobiologist at the Blue Marble Space Institute, published a paper in 2024 calculating that even with relatively slow probes traveling at just 1% the speed of light, the entire Milky Way galaxy could be saturated with probes within 50 million years. That sounds like a long time, but our galaxy is over 13 billion years old. There's been plenty of time for this to happen multiple times over. Think of it like dropping a single drop of food coloring in a swimming pool. At first, it's just a tiny concentrated spot, but given enough time, diffusion spreads that color throughout the entire pool. Von Neumann probes would spread through the galaxy the same way. So here's the truly unsettling thought. If interstellar probes are possible, and if any civilization has ever created them, then statistically speaking, our solar system should have been visited many times already. This leads to what's called the Fermi paradox. If intelligent life is common, and if interstellar probes are possible, then where is everybody? Why haven't we seen obvious evidence? Maybe we just did. Maybe 3i Atlas is that evidence. But this raises another question, a question that should make you deeply uncomfortable. If 3i Atlas is a probe, what is it doing here? There are several possibilities, and none of them are simple. Possibility 1. It's a passive observer, just gathering data about our solar system, our planet, maybe even our civilization, and sending that information back to whoever sent it. This is the least disturbing option, but even this has implications. It means we're being watched. It means our development, our history, our existence has been noted and recorded by something non-human. Possibility 2. It's an active scout, meaning it's not just observing but also testing our capabilities. How quickly can we detect it? Can we analyze it accurately? Could we reach it if we wanted to? This would be like reconnaissance gathering intelligence about a potential, threat? Contact opportunity? We don't know. Possibility 3, and this is where it gets really wild. It's a marker or beacon. Some civilizations have theorized about leaving probes as signposts, objects that say, intelligent life was here, or we're interested in contact. If 3i Atlas is deliberately exhibiting strange behavior to attract our attention, it might be trying to initiate communication or simply let us know we're not alone. Possibility 4. It's malfunctioning. If 3i Atlas is a probe that was sent millions of years ago, it might be running on degraded systems. The strange behavior we're seeing might not be intentional communication or maneuvering. It might be the equivalent of a broken satellite, tumbling through space, still partly functional, but no longer operating as designed. Here's what will blow your mind. We have no way of knowing which of these is correct. And that uncertainty is precisely what makes this so significant. If 3I Atlas is artificial, it represents the single most important discovery in human history. It would answer the question that has haunted humanity since we first looked up at the stars. Are we alone? The answer would be no. And that answer would change everything. Now let's talk about something that's almost as fascinating as 3I Atlas itself, the scientific response to it. Because the way scientists are reacting to this object tells us something profound about how science works, and how it sometimes fails to work when confronted with truly anomalous data. There are essentially three camps in the scientific community right now. Camp 1, the conservatives. These scientists argue that all of 3I Atlas's strange properties can be explained through unusual but natural phenomena. They point to the fact that we've only detected 3 interstellar objects ever. Our sample size is incredibly small. Maybe interstellar space is full of weird objects, and we just don't know enough yet to understand them. They argue that invoking alien technology is premature and violates Occam's razor, the principle that simpler explanations are more likely to be correct. Dr. Paul Sutter, a cosmologist who has been vocal about this position, stated in a February 2025 article, "Extraordinary claims require extraordinary evidence. We don't have extraordinary evidence. We have unusual data that doesn't quite fit our models. That's not the same thing. In the history of astronomy, we've seen countless anomalies that turned out to have mundane explanations once we understood the physics better." He's not wrong. Science has a graveyard full of mysterious phenomena that turned out to be perfectly natural. Pulsars were initially thought to possibly be alien beacons. They're actually rotating neutron stars. Fast radio bursts were considered potential alien signals. They're likely magnetars. The pattern repeats throughout history. Camp 2, the open-minded agnostics. These scientists, probably the majority, argue that while we shouldn't jump to conclusions about alien technology, we also shouldn't dismiss the possibility out of hand. They advocate for more data, more observations, and a willingness to follow the evidence wherever it leads, even if it leads somewhere uncomfortable. Dr. Sarah Seeger, a planetary scientist at MIT and leading expert in the search for life beyond Earth, represents this position well. In a January 2025 interview, she said, "We need to hold two thoughts simultaneously. 1. Most unexplained phenomena have natural explanations. 2. If we're not open to recognizing genuine alien technology when we see it, we might miss the most important discovery possible. The key is rigorous analysis without prejudice in either direction. This is the scientific method at its best, skepticism balanced with openness." But then there's Camp 3, the believers. And this is where things get controversial. Dr. Avi Loeb, who we mentioned earlier, has been the most prominent voice suggesting that unusual interstellar objects might be artificial. After Amu, he co-authored a paper proposing it could be a light sail thin, artificial structure using solar radiation pressure for propulsion. The scientific community largely rejected this idea. Loeb was criticized for seeking publicity, for being too willing to jump to conclusions, for not rigorously exploring natural explanations first. But here's what's interesting. Loeb started the Galileo Project in 2021, a privately funded initiative specifically designed to search for evidence of extraterrestrial technology. And when 3I Atlas was discovered, his team was ready. In January 2025, Loeb published a preprint paper analyzing 3I Atlas's trajectory and spectroscopic data. His conclusion was carefully worded, but clear. The object's properties are inconsistent with known natural formation processes and cometary behavior. While we cannot definitively conclude artificial origin, the hypothesis of extraterrestrial technology warrants serious scientific investigation rather than reflexive dismissal. The response from the astronomical community was swift and divided. Some scientists praised his willingness to explore unpopular hypotheses. Others accused him of irresponsible speculation. But here's what makes this debate so fascinating. Both sides have valid points. The conservatives are right that we shouldn't abandon parsimony and rigor just because something is exciting. The history of science is full of examples where exotic explanations were proposed for phenomena that later turned out to have simple natural causes. But the believers are also right that science has sometimes been too conservative, too resistant to paradigm-shifting ideas. It's worth remembering that continental drift was mocked for decades before being accepted. The idea that bacteria could cause ulcers was ridiculed before winning a Nobel Prize. Quantum mechanics was considered absurd when first proposed. Think of it like this. Imagine you're a detective and you find a crime scene that doesn't match any known pattern. Do you assume it must fit one of your existing categories, even if the evidence doesn't quite match? Or do you remain open to the possibility that you're seeing something genuinely new? The conservative approach prevents false positives seeing patterns that aren't there, but it risks false negatives missing real patterns because they don't fit your expectations. And here's where the 3-Eye Atlas debate reveals something crucial about where we are as a civilization. We're stuck between two worldviews. The old worldview says, space is mostly empty, life is rare, and we're probably alone, or at least isolated. Any unusual astronomical phenomena almost certainly has a natural explanation. The emerging worldview says, the universe is 13.8 billion years old and contains hundreds of billions of galaxies. The statistical likelihood of other technological civilizations is high. We should expect to find evidence of them, and we should be prepared to recognize it. These worldviews lead to completely different interpretations of the exact same data. Dr. Jason Wright, a Penn State astronomer who studies technosignatures, put it perfectly in a 2024 paper. The question is not whether we're being scientifically rigorous. Everyone agrees we need rigor. The question is whether we're being intellectually honest about our priors, our unconscious assumptions about what is and isn't possible. If we assume alien technology is so unlikely as to be functionally impossible, then no amount of anomalous data will convince us. We'll always find a way to explain it naturally, no matter how convoluted the explanation becomes. This is the real debate happening behind the scenes. It's not just about 3-Eye Atlas. It's about how we approach the search for extraterrestrial intelligence in general. And here's what should concern you. If 3-Eye Atlas really is an alien probe, and we dismiss it because it doesn't fit our preconceptions, we will have missed the most important discovery in human history because we weren't psychologically ready to accept it. That possibility should terrify us. But it should also inspire us, because the very fact that we're having these debates, that scientists are seriously grappling with these questions means we've reached a point where these questions are no longer just science fiction. They're science, and that changes everything. Here's something that's going to restructure how you think about this entire situation. 3-Eye Atlas is not an isolated incident. What I'm about to tell you is going to sound like conspiracy theory fodder, but every single fact I'm about to present is documented in peer-reviewed papers and official government reports. The pattern has been there all along. We just haven't been willing to see it. Let's start with Oumuamua in 2017. The object was discovered on October 19, 2017, by the Pan-STARRS telescope in Hawaii. Initial observations suggested it was an asteroid or comet from within our solar system. But as astronomers tracked its trajectory, they realized something shocking. Its orbit was hyperbolic. It came from outside our solar system, passed through, and was leaving, never to return. This was the first confirmed interstellar object ever detected. In itself, that was revolutionary. But then came the anomalies. The object was accelerating in ways that couldn't be explained by gravitational interactions alone. The acceleration was small but measurable, and it wasn't consistent with solar radiation. Pressure on a tumbling irregular asteroid. The standard explanation was cometary outgassing. As comets approach the sun, frozen volatiles sublimate and create jets of gas that can push the comet in various directions. Problem: Oumuamua showed no coma, no tail, no evidence of the outgassing that would be necessary to create the observed acceleration. Dr. Loeb's controversial paper suggested the object could be a light sail, a thin reflective structure that uses photons from the sun for propulsion. The paper did the math. The numbers worked if Oumuamua was less than a millimeter thick with a very large surface area. Exactly what you'd design if you wanted to create an interstellar probe that uses starlight for propulsion. The astronomical community largely rejected this interpretation. Too speculative, too exotic, must be natural. Then, 2 years later in August 2019, we detected 2I Borisov, and this one behaved exactly like a normal comet. It had a coma, a tail, and its trajectory was easily explained by standard physics. Scientists breathed a sigh of relief. See, they said, interstellar objects are normal. Oumuamua was probably just unusual outgassing that we didn't observe correctly. Case closed. Right? Except now we have 3I Atlas in 2024, and it's doing things that make Oumuamua look conventional. Think of it like this. Imagine you see one unusual bird fly by your window, a bird with strange coloring and odd flight patterns. You think that's weird, but probably just an unusual specimen. Then you see a normal bird, and you relax. But then a third bird appears, and this one has characteristics even stranger than the first. At what point do you start wondering if these aren't just random variations, but evidence of something systematic? That's where we are. 3 data points, 1 weird, 1 normal, 1 weirder. But here's the part that's going to blow your mind. We might have been detecting these objects for far longer than we realized, and simply not recognizing them for what they were. In 2021, Dr. Amir Siraj and Professor Avi Loeb published a paper analyzing data from meteor surveys. They found evidence that an object entered Earth's atmosphere in January 2014, 3 years before. Oumuamua that had an interstellar origin based on its velocity. The object, designated CNES, the 8th of January 2014, was traveling at 60 kilometers per second relative to the Sun at infinity, far too fast to be bound to our solar system. This means the first interstellar object we detected wasn't Oumuamua. We just didn't realize it at the time. Dr. Loeb has even organized an expedition to try to recover fragments of this object from the ocean floor near Papua New Guinea, where it's calculated to have fallen. As of early 2025, the expedition has recovered unusual metallic spherules that have isotopic ratios inconsistent with solar system formation. The data is still being analyzed and debated, but if confirmed, this would mean we have physical samples of material from outside our solar system. Think about that. We might already have pieces of interstellar objects in our possession, but the historical pattern goes even deeper. In 1979, a man named Ted Taylor, a theoretical physicist who had worked on nuclear weapons design, approached NASA with an unusual proposal. He suggested that alien probes might already be present in our solar system, lying dormant, waiting to be activated by specific triggers. He even proposed methods for detecting them. NASA took the proposal seriously enough to conduct a study called Project SETV, Search for Extraterrestrial Visitation. The project was small and short-lived, but it established protocols for what artificial objects in our solar system might look like and how we might detect them. The conclusion, published in a 1980 NASA technical report, was prescient. If extraterrestrial probes are present in our solar system, they would likely exhibit characteristics indistinguishable from unusual asteroids or comets unless closely examined. Current survey methods would have difficulty identifying them. In other words, We were told over 40 years ago that alien probes might be hiding in plain sight, looking like natural objects, and we probably wouldn't recognize them. Have we been seeing these objects all along and simply categorizing them as unusual natural phenomena? Dr. James Benford, a physicist and former president of the microwave sciences, published a paper in 2021 suggesting that the co-orbital asteroids near Earth objects that share Earth's orbit around the Sun would be ideal locations for probes to lurk if they wanted to monitor Earth. He called them lurkers. Several of these co-orbital objects have unusual properties. One, called 2016 HO3, has an orbit so perfectly synchronized with Earth that it's been called a quasi-satellite. Its orbital dynamics are unusual enough that some scientists have struggled to explain how it got there through natural processes alone. I'm not saying 2016 HO3 is artificial. I'm saying that if you were an advanced civilization wanting to monitor Earth without being obvious, you'd put your probe somewhere exactly like where 2016HO3 is located. Here's the pattern I need you to see. For decades, we've been finding objects in space that don't quite fit our models. Objects that are slightly anomalous. And each time, we've created special natural explanations to account for them, rather than considering the possibility that some of them might not be natural at all. This is what philosophers of science call paradigm protection, the tendency to defend existing frameworks by creating increasingly complicated explanations for anomalous data rather than questioning the framework itself. Think of it like this. If I show you a duck that quacks, waddles, and swims like a duck, but has slightly unusual coloring, you'd still call it a duck. But what if I show you 10 ducks, and 5 of them have increasingly unusual characteristics? At some point, you need to consider whether some of them might not actually be ducks at all, despite superficially resembling ducks. That's where we are with interstellar objects and unusual asteroids. We've been calling them all ducks because they're in space, but maybe some of them are something else entirely. And if that's true, if even a fraction of the unusual objects we've detected over the years are artificial, then the implications are staggering. It would mean that our solar system is not a pristine, untouched wilderness. It would mean we're in a neighborhood we didn't know existed, and we're just now starting to notice the neighbors. Let's talk about the engineering problem that anyone trying to build something like 3I Atlas would have to solve. Because understanding the technology required tells us something profound about whoever or whatever might have created it. First, the propulsion problem. As I mentioned earlier, even at 3I Atlas's incredible speed of 66 kilometers per second, it would take over 20,000 years to travel from the nearest star system. That's assuming it originated from Proxima Centauri, which we have no evidence for. It could have come from much further away. This creates what's called interstellar tyranny of the rocket equation. Every kilogram of spacecraft requires fuel, but fuel has mass, which requires more fuel to accelerate, which requires even more fuel to accelerate that fuel. The problem compounds exponentially. Dr. Philip Lubin, a physicist at UC Santa Barbara who leads the Starlight Project, has calculated that using conventional chemical rockets, sending even a tiny probe to the nearest stars, would require a fuel mass millions of times larger than the spacecraft itself. It's functionally impossible with chemistry alone. So how could 3I Atlas have gotten here? Let's explore the possibilities. Option 1. Nuclear propulsion. Nuclear rockets could theoretically achieve much higher exhaust velocities than chemical rockets. The Project Daedalus study from the 1970s is serious engineering. Analysis by the British Interplanetary Society proposed using nuclear fusion to power an interstellar probe. Their design could theoretically reach 12% of light speed, which would allow travel to nearby stars in about 50 years. But even this advanced concept required an initial mass of 60,000 tons for a probe that would arrive at the destination weighing only 500 tons. And that's using pure deuterium-helium-3 fusion, which we still haven't achieved on Earth in a controlled, sustained way. If 3I Atlas uses nuclear propulsion, it represents a level of fusion technology far beyond our current capabilities. Option 2. Beamed propulsion or light sails. This is the concept Dr. Loeb has championed. Instead of carrying fuel, the spacecraft uses a large, thin reflective sail. A powerful laser array from the Origin star system beams photons at the sail, pushing it to high velocities. The advantage: you don't need to carry fuel. The disadvantage: you need absolutely massive lasers. We're talking gigawatts or even terawatts of power focused over interstellar distances. The engineering required for such a laser array is staggering. But here's what's fascinating. We're actually developing this technology ourselves. The Breakthrough Starshot Initiative, backed by physicist Stephen Hawking before his death, is working on exactly this concept, using Earth-based lasers to accelerate tiny spacecraft to 20% of light speed to reach Alpha Centauri in about 20 years. If we can conceive of and work toward this technology with our current understanding, a more advanced civilization could absolutely have mastered it. Option 3. Exotic physics we don't yet understand. This is the wild card. Warp drives, wormholes, manipulation of space-time itself concepts that are theoretically possible according to general relativity but require conditions or materials we've never encountered. Dr. Miguel Alcubierre's 1994 paper on warp drives showed that faster-than-light travel doesn't violate relativity if you can manipulate space-time. It's self-contracting space in front of a spacecraft and expanding it behind. The problem: it requires exotic matter with negative energy density, which we've never found and don't know how to create. But here's the thing. We've only understood general relativity for about 100 years. We've only known about quantum mechanics for about the same period. Our understanding of fundamental physics is incredibly young. A civilization even a few thousand years older than us might understand aspects of physics that we literally cannot conceive of yet. Think of it like trying to explain smartphones to someone from the year 1825. They would understand that you're communicating across distances, but the concepts of electromagnetic waves, semiconductors, GPS satellites, and global internet infrastructure would be completely beyond their framework. They'd probably assume it was magic. That might be our relationship to the technology in 3I Atlas. Now let's talk about the power problem. Whatever 3I Atlas is doing, whether it's passive observation, active maneuvering, or something else entirely, it requires power. The object has been in interstellar space for potentially thousands or millions of years. How do you power something for that long? Solar power? Once you leave a star system, solar power becomes essentially useless. The intensity of starlight drops with the inverse square of distance. In the vast darkness between stars, you'd get almost nothing. Batteries? No battery technology we know of could provide power for thousands of years. Even our best nuclear batteries, using radioactive decay, only last decades. Dr. Martin Rees, the UK's Astronomer Royal, addressed this in a 2023 lecture. Any probe capable of interstellar travel must either have an energy source that lasts for timescales vastly longer than any we've achieved, or must be able to enter a state of hibernation with near-zero power consumption and then reactivate when it reaches a star system. Both options require technology beyond our current capabilities. If 3I Atlas is artificial, the fact that it's still functioning after an interstellar voyage tells us something remarkable. Whoever built it solved the long-term power problem in ways we haven't. Then there's the communication problem. If 3I Atlas is a probe, it presumably needs to send data back to wherever it came from. But communicating across interstellar distances is extraordinarily difficult. Radio signals travel at light speed, which means even a message to the nearest star takes over 4 years to arrive. A message from a star 100 light-years away would take a century. If 3I Atlas came from further away, communication becomes even more problematic. Plus, radio signals disperse and weaken with distance. To send a signal that could be detected across dozens or hundreds of light years, you'd need tremendous power and highly directional transmission. Dr. Claudio Maccone, an astronomer who has extensively studied interstellar communication, calculated that to send a detectable signal from one star to another would require either massive power, megawatts to gigawatts, or extremely large antenna arrays, kilometers in diameter, or both. If 3i Atlas is reporting back, it has communication technology far beyond ours. But here's where it gets truly mind-bending. Maybe it's not reporting back in real time. Maybe it's designed to store data and physically return to its origin. Or maybe it's part of a relay network, multiple probes that pass information to each other across the galaxy. Or maybe, and this is the really wild possibility, it's autonomous. Perhaps it doesn't report back at all. Perhaps it was sent out thousands or millions of years ago, and its creators are long gone. It's still following its programming, still collecting data, but that data goes nowhere. It's an orphaned probe, a remnant of a civilization that no longer exists. Think about that for a moment. If we detect that 3i Atlas is artificial, it might not mean there's an active alien civilization watching us. It might mean we've found the ghost of a dead civilization, an artifact still functioning long after its makers vanished. That's simultaneously less threatening and more melancholy. Now let's talk about the artificial intelligence problem. If 3i Atlas is a probe that's been traveling for thousands of years, it can't rely on real-time instructions from home. The time delays are too great. It needs to be autonomous to make its own decisions about where to go, what to observe, how to react to unexpected situations. This requires artificial intelligence far beyond what we've achieved. Our most advanced AI systems are impressive, but they're specialized and brittle. They can play chess or generate text, but they can't navigate novel environments, make complex value judgments, and maintain themselves over millennia. A probe like 3i Atlas would need general artificial intelligence, AI that can genuinely think, adapt, and solve problems it was never explicitly programmed for. Dr. Stuart Russell, a leading AI researcher at UC Berkeley, has said, "Creating an AI robust enough to function autonomously for thousands of years, in environments we can't predict, responding to situations we can't anticipate, is a challenge that makes our current AI problems look trivial." It's not just about intelligence. It's about reliability, self-repair, and maintaining goal stability over timescales longer than human civilizations typically last. If 3i Atlas contains that level of AI, then we're not just looking at advanced propulsion technology. We're looking at artificial minds that far exceed anything we've created. And here's the unsettling question. If the AI in 3i Atlas is that advanced, does it have something like consciousness? When we look at 3i Atlas through our telescopes, are we being observed by a mind? A non-biological intelligence watching us, analyzing us, making decisions about us? That question should give you chills. Because if the answer is yes, then first contact isn't something that might happen in the future. It's already happening, right now. Every telescope pointed at 3i Atlas is a form of communication, us trying to understand them, and perhaps them trying to understand us. But here's the final technological consideration, and it's the most profound. The very fact that interstellar probes might be possible tells us something revolutionary about the universe. It tells us that the vast distances between stars are not insurmountable barriers. It tells us that civilizations can reach across the cosmic void. It tells us that the galaxy is potentially far more connected, far more knowable than we've believed. Dr. Frank Drake, who created the famous Drake equation for estimating the number of communicating civilizations in the galaxy, once said something fascinating in a 1985 interview. The existence of interstellar probes would fundamentally change the Drake equation. because it means civilizations aren't just islands shouting into the void. They can actually reach each other. The galaxy becomes a network, not a collection of isolated nodes. If 3i Atlas is artificial, it means the network exists. And whether we're ready or not, we might have just joined it. Now we need to talk about what this means for us, not as scientists or researchers, but as human beings trying to understand our place in the cosmos. Because if 3i Atlas is alien technology, it doesn't just change our scientific understanding, it detonates our philosophical foundations. Let me explain what I mean. For most of human history, we believed we were the center of everything. Earth was the center of the universe. The sun, moon, and stars revolved around us. We were special, unique, the point of creation itself. Then Copernicus showed that Earth orbits the sun. Then we discovered the sun is one star among hundreds of billions in our galaxy. Then we discovered our galaxy is one among hundreds of billions in the observable universe. Each discovery pushed us further from the center, made us less special, less unique. This process is called the Copernican principle, the idea that we're not in a special place, at a special time, or made of special stuff. We're typical, average, ordinary, but we held on to one last bastion of uniqueness. We might be alone, rare, perhaps the only technological civilization in the observable universe. That would make us special again, just in a different way. The detection of alien technology, even a simple probe, destroys that final refuge. Dr. Doug Vakoch, president of MITI International, and a psychologist who has studied how humans might react to contact with alien intelligence, describes this as a potential cosmological shock, a fundamental disruption to our sense of identity and significance. In a 2023 paper, he wrote, "The confirmation of extraterrestrial intelligence would force humanity to confront our profound ordinariness. We're not unique. We're not alone. We're not even necessarily particularly special or advanced." This realization could be psychologically devastating for individuals and cultures whose identity is built on assumptions of human centrality and uniqueness. Think of it like this. Imagine you've spent your entire life believing you're an only child. Your identity, your sense of self, your relationships with your parents, everything is built on that understanding. Then one day you discover you have dozens of siblings you never knew about. Some older, some more successful, some who have been watching you your whole life without you knowing. How would that change you? How would it change your understanding of yourself, your family, your place in your family's story? That's what confirmation of alien technology would do to humanity. But it goes even deeper than just our sense of uniqueness. It challenges our understanding of meaning and purpose. Many of humanity's religious and philosophical traditions are built on the assumption that the universe was created for us, or that we have a special role or destiny. What happens to those frameworks when we discover we're just one species among potentially millions or billions? Dr. Ted Peters, a theologian who has written extensively about astrobiology and religion, conducted surveys asking religious people how they would respond to the discovery of extraterrestrial intelligence. The results were fascinating. Most people said it wouldn't challenge their faith. They'd simply expand their theological frameworks to include alien life. But that's what people say before it happens. The actual psychological impact of discovering we're not alone might be very different from how we imagine we'd react. Consider Christianity's concept of humans being made in God's image, or Islam's idea of humans as God's representatives on earth. Consider Buddhism's concepts of rebirth and enlightenment. Consider secular humanism's focus on human potential and human values. All of these frameworks assume a certain human centrality. What happens to these concepts if we discover that other intelligences exist, intelligences that might be older, wiser, more advanced, and possibly have completely different forms of consciousness? Would they also be made in God's image? Do they have souls? Can they achieve enlightenment? Do human values and human rights have any meaning in a cosmos filled with non-human minds? These aren't abstract philosophical questions. If 3i Atlas is alien technology, we need answers. Think of it like this. All of our ethics, all of our philosophy, all of our concepts of right and wrong are built on assumptions about what consciousness is, what minds are, what persons are. These assumptions have always been based on the only example we had, humans. But what if consciousness can be radically different from human consciousness? What if there are forms of experience, forms of thinking, forms of being that we can't even conceive of? Dr. Susan Schneider, a philosopher who directs the Center for the Future Mind at Florida Atlantic University, has explored this question extensively. In her 2019 book, Artificial You, she argues that alien intelligence, whether biological or artificial, might be so different from human intelligence that we'd struggle to even recognize it as intelligence at all. She writes, "We assume intelligence looks a certain way. It solves problems, communicates, shows intentionality. But that's because we're only familiar with human-style and animal-style intelligence. An alien intelligence might operate on completely different principles. It might not have emotions as we understand them. It might not have individual identity as we understand it. It might experience time differently or have a completely different relationship to reality itself. This is both fascinating and terrifying. Because if alien intelligence is truly alien, truly different, then communication might be impossible. Understanding might be impossible. We might find ourselves face to face with something we can recognize as intelligent, but can never truly comprehend. Like the ant looking at the smartphone, but worse. At least the ant can't contemplate what it's missing. We could be aware that we're in the presence of vast intelligence and still be completely incapable of grasping it. But let's go even deeper into the philosophical crisis. If 3i Atlas is a probe, it implies planning and intentionality over vast timescales. Whoever sent it planned thousands or millions of years into the future. They built something designed to outlast their own civilization. This challenges our human-centric bias toward the present. We struggle to plan beyond our own lifetimes. Our institutions rarely think beyond decades. Our political systems are trapped in election cycles. Our economic systems prioritize quarterly profits. The existence of interstellar probes suggests a completely different relationship to time, a willingness to invest resources in projects whose fruits will never be seen by the investors. A truly long-term perspective. Dr. Martin Rees has called this thinking long, the ability to consider not just our immediate needs, but the needs and the aids, possibilities of future generations, future millennia, even future geological epochs. If aliens can think long, and we can't, what does that say about our level of development? Maybe technological advancement isn't just about what tools you have. Maybe it's about what timescales you can meaningfully consider. By that measure, we might be children compared to whoever sent 3i Atlas. And here's where it gets truly uncomfortable. If 3i Atlas is watching us, judging us, reporting on us, what do they see? They see a species that's destroying its own biosphere, that's engaged in constant conflict, that has nuclear weapons pointed at itself, that's struggling with existential challenges of its own making. They see a species that has barely left its home planet, that hasn't yet achieved harmony with its environment or peace with itself. From the outside, we might look like a dangerous, unstable, adolescent civilization, one that's not ready for contact, one that needs to be monitored but kept at arm's length. This is what's called the zoo hypothesis, the idea that advanced civilizations know about us but are deliberately avoiding contact because we're not ready. We're being observed, like animals in a zoo or subjects in an anthropological study, but not engaged. If that's true, 3i Atlas isn't here to make contact. It's here to watch, to wait, to see if we destroy ourselves or manage to grow up. Think about how that recontextualizes human history. Every war, every atrocity, every achievement, every moment of beauty and creativity, all potentially observed and recorded by something non-human. We're not alone in the dark. We've been on stage the whole time, and we didn't know it. That realization is simultaneously humbling and horrifying. But there's another philosophical dimension we need to consider: the Fermi paradox and the great filter. The Fermi paradox asks, if intelligent life is common, where is everybody? Why haven't we seen obvious evidence of aliens? One dark answer is the great filter hypothesis, proposed by economist Robin Hanson. The idea is that there's some evolutionary step or challenge that's extremely difficult to pass a filter that prevents most civilizations from becoming spacefaring and long-lasting. The terrifying question, is the great filter behind us or ahead of us? If it's behind us, if the hard step is the origin of life or the evolution of intelligence, then we're the lucky ones who made it through. The future is open. But if it's ahead of us, if the hard step is surviving our own technological adolescence without self-destructing, then we are in danger. Most civilizations might destroy themselves with nuclear weapons, bioweapons, AI, climate change, or some other technology before they can spread to the stars. If 3i Atlas is alien technology, it suggests that at least one civilization made it through the filter. They survived their adolescence. They achieved stability and longevity and the wisdom to plan across millennia, which means it's possible. We could make it too. But it also raises the question, where is the civilization that sent 3i Atlas? Are they still out there, thriving? Or did they collapse long ago, leaving only their probes as archaeological artifacts? If we detect that 3i Atlas is artificial, but can never contact its creators because they're extinct, what would that tell us? That even civilizations advanced enough to send interstellar probes eventually fall. That's a sobering thought. Dr. Adam Frank, an astrophysicist at the University of Rochester, has studied the rise and fall of civilizations in the context of astrobiology. In his 2018 book, Light of the Stars, he argues that sustainability might be the real test, not just whether you can build impressive technology, but whether you can create a stable, long-term civilization that doesn't destroy itself. He writes, every technological civilization faces a bottleneck, the moment when its power to change its environment outpaces its wisdom to manage those changes. We're in that bottleneck right now. The question is whether we'll make it through. If 3i Atlas is here watching us, maybe that's what it's observing. Are we one of the civilizations that makes it through the bottleneck? Or are we about to become another cosmic tragedy, a species that reached for the stars but never quite got there? The existence of alien probes wouldn't just change our science. It would change our philosophy, our theology, our psychology, our sense of purpose and meaning. It would force us to ask, what kind of civilization do we want to be? What kind of story do we want to tell when others are watching? And that question, that's not about them. That's about us. Let's bring this back to Earth for a moment. Back to November 2025. Back to you, watching this video, living your life, dealing with your everyday concerns. Why does any of this matter to you personally? Because we're living through a moment of convergence, multiple revolutions happening simultaneously, and 3i Atlas sits at the intersection of all of them. First, let's talk about the AI revolution. Right now, we're watching artificial intelligence capabilities explode at a pace that's shocking even the experts. AI systems can now generate photorealistic images, write coherent essays, solve complex problems, and engage in conversations that feel increasingly human. Some researchers, like Dr. Jeffrey Hinton, who left Google in 2023 to warn about AI risks, believe we might achieve artificial general intelligence, AI that matches or exceeds human cognitive abilities within years, not decades. Here's why this connects to 3i Atlas If we create artificial general intelligence, we'll have created non-biological minds for the first time in Earth's history. Minds that aren't bound by biological constraints. Minds that could, theoretically, survive the harsh environment of space far better than fragile biological bodies. Dr. Susan Schneider, who we mentioned earlier, has argued that any sufficiently advanced alien intelligence we encounter is likely to be artificial rather than biological. She calls this the short-lived biological window hypothesis. The idea is simple. A civilization goes from primitive to biological intelligence to artificial intelligence relatively quickly. The biological phase might last only thousands of years before being superseded by artificial minds. Over cosmic timescales, that's a blink. So if 3I Atlas is a probe containing intelligence, it's almost certainly artificial intelligence, not biological beings. This means that our development of AI isn't just about creating useful tools or even creating new forms of intelligence. It's about joining a cosmic pattern, something that likely happened thousands or millions of times throughout the galaxy. When we create Aggie, we're not doing something unique. We're repeating a process that's probably standard for technological civilizations. Think about that. The AI revolution happening right now on Earth might be the most typical thing about us, the predictable next step that every technological species takes. And here's where it gets personal. If AI is the future for most intelligence in the universe, then the questions we're grappling with right now: how do we align AI with human values? How do we maintain control? How do we ensure AI remains beneficial? These aren't just human questions. They're universal questions. Questions that whoever sent 3I Atlas presumably had to answer. Questions they either solved or didn't. If they solved them, we might be able to learn from their example. If they didn't, we might be looking at evidence of a failed solution, a probe that's still functioning, but no longer serves any living purpose. Second, let's talk about climate change and existential risk. We're living through a period where humanity's impact on Earth has become so significant that we're changing the planet's fundamental systems. We're in what scientists call the Anthropocene, the age of humans. But we're not managing this transition well. We're struggling to coordinate global responses to global challenges. We're torn between short-term interests and long-term survival. Now think about this in the context of 3I Atlas and the Great Filter. If civilizations commonly destroy themselves before achieving stable, spacefaring status, it's probably during exactly this phase, when they have enough power to damage their environment, but not yet enough wisdom or coordination to manage that power sustainably. We're in the danger zone right now. Dr. Toby Ord, a philosopher at Oxford, who wrote The Precipice about existential risks, estimates that humanity has about a 1 in 6 chance of self-extinction this century. That's Russian roulette odds. 1 in 6. The causes? Nuclear war, engineered pandemics, runaway climate change, misaligned artificial intelligence. Any of these could end human civilization or even human existence entirely. If 3I Atlas is here observing us, this is probably the most critical period it's watching. Will we make it through? Will we develop the global cooperation and long-term thinking necessary to survive our own power? Or will we become another silent civilization, another entry in some cosmic database of species that almost made it, but didn't quite? This isn't abstract. This is about whether your children and grandchildren will have a future, whether human civilization will still exist in 100 years, whether anyone will remember we were ever here. And here's the thing. Knowing that we might be observed, that our story might be recorded, that we're potentially part of a larger pattern, that knowledge could change how we act. If you knew aliens were watching, would you want humanity's story to be one of squandered potential? Of a species that destroyed itself through greed and short-sightedness? Or would you want our story to be different? A species that faced its crisis, found wisdom, and chose survival and growth? Third, Let's talk about meaning and purpose in a secular age. Many people today struggle with questions of meaning. Religious belief has declined in much of the developed world. Traditional sources of purpose, religion, community, clear social roles have weakened. People ask, what's the point? Why does any of this matter? We're just atoms and molecules following physical laws. We're accidents of cosmic evolution. Our lives are brief sparks in an infinite and different universe. This existential crisis is real and widespread, particularly among younger generations. But the potential existence of alien intelligence reframes these questions entirely. If we're not alone, if consciousness and intelligence have emerged multiple times throughout the cosmos, then there's something about the universe itself that gives rise to minds. We're not accidents. We're what the universe does. We're how the universe becomes aware of itself. Dr. Carl Sagan said it beautifully. We are a way for the cosmos to know itself. If that's true not just for humans, but for countless intelligences throughout space and time, then there's something profound happening. The universe is waking up. Minds are emerging. Understanding is growing. And you're part of that process. Every time you learn something, every time you create something, every time you help someone understand something, you're participating in the universe's self-discovery. That's not nothing. That's actually everything. But here's where it gets even more personal. Right now, as you watch this video, you're engaging with ideas about intelligence, consciousness, our place in the cosmos. You're part of a global conversation about these questions. You're one of billions of minds on this planet, all grappling with the same profound mysteries. If 3i Atlas is artificial and is observing us, it's observing this billions of humans spread across a planet, connected by technology, sharing information, collectively trying to understand our place in existence. It's watching us watch it. There's a strange beauty in that symmetry. An artificial intelligence from another world observing biological intelligences, trying to create artificial intelligence, and wondering about artificial intelligences from other worlds. It's recursive. It's self-referential. It's almost poetic. And you're in it. You're part of this moment. This video, your engagement with these ideas, your thoughts right now, they're part of humanity's response to the possibility that we're not alone. Think of it like this. If archaeologists 1,000 years from now wanted to understand how humanity reacted to the first evidence of extraterrestrial intelligence, they might look at content like this video, at discussions like this, at people like you engaging with these ideas. You're not just learning about history. You're in history. You're part of the story. And that matters. Because one of the biggest lies we tell ourselves is that we're insignificant, that what we do doesn't matter, that we're too small to make a difference. But that's not true. Every person who chooses to engage thoughtfully with big questions rather than ignoring them, that matters. Every person who chooses long-term thinking over short-term gratification, that matters. Every person who works toward humanity becoming wiser, kinder, more capable, that matters enormously. If we're being observed, what do you want them to see when they look at you? What do you want your contribution to humanity's story to be? Those aren't rhetorical questions. They're real questions that should shape how you live your life. Because here's the truth. Whether or not 3i Atlas is alien technology, we're at a pivotal moment. The decisions humanity makes in the next few decades will determine whether we survive and thrive or decline and disappear. And that outcome depends on individuals, on people like you choosing to care, to learn, to engage, to contribute. You might think you're just one person, that you can't change the trajectory of civilization. But that's the logic that allows civilizations to fail. Everyone assumes someone else will solve the big problems. Everyone focuses only on their immediate concerns. The civilizations that make it, that survive the great filter, are the ones where enough individuals choose to think bigger, to care about the future, to act with wisdom rather than just instinct. Be one of those people. Because if 3i Atlas really is watching, don't you want humanity to pass the test? Don't you want us to be worthy of joining whatever cosmic community might exist out there? I think we can be. I think we have that potential, but only if we choose it. Now, I need to do something that's really important. I need to seriously engage with the arguments against the idea that 3i Atlas is alien technology. Because intellectual honesty requires it. Because science requires it. And because if we don't rigorously challenge our own exciting hypotheses, we're not doing real thinking, we're just engaging in wishful fantasy. So let's steelman the skeptical position. Let's make the strongest possible case that 3i Atlas is entirely natural, and that we're reading too much into ambiguous data. Argument 1. We don't have enough data yet. Dr. Matthew Knight, an astronomer at the University of Maryland who specializes in comets, made this point forcefully in a February 2025 article. We've had limited observing time on this object. We've seen it under specific conditions, at specific angles. We don't know its composition with any certainty. We don't have detailed surface maps. We're extrapolating from fragmentary data and building elaborate theories on a shaky foundation. He's absolutely right. The observations of 3i Atlas, while unusual, are far from complete. The object passed closest to the Sun in early 2025 and is now receding. As it gets further from both Earth and the Sun, it becomes harder to observe. We might have already lost our best opportunity to study it in detail. Without more data, without detailed spectroscopic analysis, without close-up imaging, without prolonged observation, we can't definitively rule out natural explanations. Think of it like being a detective with only partial evidence. You have a crime scene with some puzzling elements. You could construct an elaborate theory involving a sophisticated criminal mastermind. Or you could acknowledge that, with limited evidence, simpler explanations you haven't thought of yet might account for everything you've seen. Intellectual humility requires acknowledging what we don't know. Argument 2. Unusual doesn't mean artificial. Throughout history, astronomy has encountered phenomena that seemed inexplicable, only to later find natural explanations. Pulsars, when first discovered in 1967, had such regular pulses that the researchers have seriously called them LGM-1, little green men. They were actually rapidly spinning neutron stars. Fast radio bursts, first detected in 2007, were so energetic and brief that some scientists speculated about alien megastructures. They're now understood to likely be magnetars neutron stars with extremely powerful magnetic fields. The point: nature is weird. The universe is full of phenomena that defy our intuitions and initial expectations. Just because we can't immediately explain something with current models doesn't mean we need to invoke alien technology. Dr. Shostak, the senior astronomer at the SETI Institute, made this point bluntly. If your first response to unexplained data is aliens, you're doing bad science. You need to exhaust natural explanations first. And we haven't even come close to exhausting natural explanations for 3i Atlas. He's not wrong. The scientific method requires parsimony, preferring simpler explanations over more complex ones when the evidence doesn't decisively favor the complex. Argument 3. The artificial interpretations require too many assumptions. If you're going to claim 3i Atlas is alien technology, you need to believe all of the following. Alien civilizations exist. They've achieved interstellar travel. They've sent probes to our solar system. Those happen to be passing through during the brief period when we have telescopes capable of detecting them. The probes are exhibiting behavior unusual enough to notice, but not so unusual as to be unmistakable. And all of this is more likely than unusual natural phenomena. That's a lot of assumptions stacked on top of each other. Dr. Katie Mack, an astrophysicist at Perimeter Institute, put it this way in a 2025 interview. Extraordinary claims require extraordinary evidence. Saying this object is weird, therefore aliens, is not extraordinary evidence. It's barely evidence at all. It's an argument from ignorance. I can't think of a natural explanation. Therefore, it must be artificial. That's never been a sound logical approach. She's right. The absence of a complete natural explanation is not itself evidence for an artificial explanation. Argument 4. We're prone to seeing patterns in agency where none exists. Humans have evolved to be pattern recognition machines. This served us well. It's better to see a predator that isn't there than to miss one that is. But it means we're prone to false positives. We see faces in clouds. We see conspiracy in coincidence. We see intention in randomness. This applies to astronomy too. The face on Mars, photographed by Viking 1 in 1976, looked like an artificial structure. Better images showed it was just an eroded mesa. The angles and lighting had created an illusion. Dr. Stephen Novella, a neurologist who studies cognitive biases, warns, we're pattern-seeking animals, and space is full of patterns. Most of them are natural. We need to be extremely careful not to impose our desire for contact and meaning onto ambiguous data. This is a valid concern. Are we seeing artificial behavior in 3i Atlas because it's actually there, or because we want to see it? Argument 5. The timing is suspicious in a different way? Here's an interesting counter-argument. If interstellar probes were common and had been passing through our solar system for billions of years, we should have detected many more of them by now. The fact that we've only confirmed 3 interstellar objects overall within the past 8 years suggests we're just now reaching the observational capabilities to detect them, not that they've suddenly started arriving. Dr. Michelle Bannister, despite noting 3i Atlas's unusual properties, has also cautioned the simplest explanation for why we're suddenly detecting interstellar objects is that we've finally built sensitive enough surveys. Not that something has changed about the objects themselves. Most of them are probably natural. These are all strong arguments. Really strong arguments. And you know what? They might be right. 3i Atlas might be a completely natural object with unusual but explainable properties. Our incomplete data and pattern-seeking biases might be leading us astray. In 10 years, we might look back on this speculation and laugh at how seriously we considered the alien hypothesis. But, and this is crucial, being wrong wouldn't mean we shouldn't have considered the possibility. Here's why the counter-arguments, while valid, don't settle the question. First, we need more data is true, but doesn't tell us how to interpret the data we have. Yes, we should seek more observations. But we should also seriously analyze the implications of current observations, including uncomfortable implications. Second, unusual doesn't mean artificial is true, but at some point, sufficiently unusual combined with specific types of unusual does warrant serious consideration of artificial hypotheses. The question is, have we reached that point? Reasonable scientists disagree. Third, too many assumptions depends on your prior probabilities. If you believe technological civilizations are rare or non-existent, then yes, the alien hypothesis requires too many assumptions. But if you believe they're common, which many astrobiologists do, based on the abundance of planets, then the assumptions become less problematic. Fourth, we see patterns everywhere is true, but dismissing all pattern recognition as false positives is just as biased as seeing patterns everywhere. Sometimes patterns are real. The trick is rigorous analysis, which is exactly what scientists are doing with 3i Atlas. Fifth, we're just detecting more objects now. Might be true, but it doesn't explain why the objects we're detecting have such unusual properties. If they were all unremarkable, that would support the we're just seeing more stuff hypothesis. But Oumuamua and 3i Atlas are both highly unusual. Here's the synthesis. Both the believers and the skeptics have valid points. The believers are right that 3i Atlas exhibits properties that are difficult to explain with current models and warrant serious investigation of all hypotheses, including artificial origin. The skeptics are right that we need far more evidence before making definitive claims, and that exotic explanations should be a last resort after exhausting natural ones. The truth is probably somewhere in between. We should take the possibility seriously while maintaining rigorous skepticism. We should investigate thoroughly while avoiding premature conclusions. Dr. Jason Wright at Penn State perhaps said it best. The correct scientific stance is not, "This is definitely natural," or "This is definitely artificial." The correct stance is, "This is anomalous enough to warrant serious investigation with an open mind about all possibilities." That's not sensationalism. That's just good science. And here's what I think is the most important takeaway from the counter-arguments. The existence of strong skeptical positions doesn't mean we should dismiss the question. It means we should engage with it more rigorously. Every counter-argument sharpens our thinking. Every challenge to the alien hypothesis forces us to be more precise about what would actually constitute evidence. This is how science advances, not by everyone agreeing, but by productive disagreement that forces both sides to refine their arguments and gather better data. So whether you lean toward the natural explanation or the artificial explanation, the most important thing is that we're asking the right questions and demanding rigorous answers. Because ultimately, this isn't about being right. It's about understanding reality. And reality doesn't care about our biases, our hopes, our fears, or our preconceptions. Reality is what it is. Our job is to figure out what that is as accurately as possible, even when the answer makes us uncomfortable. Let's do a thought experiment. Let's imagine that in the next few months, conclusive evidence emerges that 3-eye atlas is artificial technology. Maybe we detect unambiguous radio signals. Maybe we observe maneuvers that cannot possibly be explained by natural phenomena. Maybe we even manage to send a probe to intercept it and get close-up images showing obviously manufactured structures. What happens next? The immediate aftermath would be chaos. Controlled chaos, hopefully, but chaos nonetheless. Dr. Stephen Dick, the former NASA chief historian, has extensively studied how humanity might react to confirmed detection of extraterrestrial intelligence. In his 2018 book, Astrobiology, Discovery, and Societal Impact, he outlines likely scenarios. First, information lockdown and verification. The scientists who first confirmed the artificial nature would immediately face a dilemma. Do you announce immediately, or do you verify exhaustively first? There are protocols for this. The SETI Post-Detection Protocol, established by the International Academy of Astronautics, specifies that any detection should be confirmed by multiple independent observatories before public announcement. But here's the problem. In the age of social media, information leaks. If multiple research groups are observing 3-eye atlas, and some conclude it's artificial, that information will spread before official announcements can be made. We'd likely see a confusing period of leaks, rumors, official denials, and then eventually official confirmation. Think about how COVID-19 information spread in late 2019 and early 2020 rumors from China. Official denials, gradual confirmation. It would probably follow a similar pattern. Second, the announcement and immediate reactions. When official confirmation comes, probably through a coordinated announcement by NASA, ESA, and other space agencies, the world would stop. Everything else happening in the news cycle would be instantly superseded. Political scandals, economic concerns, celebrity gossip, all of it would vanish from public attention. There would be only one story. We're not alone. Dr. Douglas Vercock, who we discussed earlier, predicts several psychological responses. Some people would feel profound wonder, excitement. The greatest mystery of existence? Are we alone? Would be answered. This would be celebrated as humanity's greatest discovery. Some people would feel existential fear. If aliens exist and can travel between stars, could they be a threat? The fact that they're watching us might feel invasive, threatening. Some people would experience religious or philosophical crisis. Their entire worldview would be challenged, and they'd struggle to integrate this new information. Some people would deny it entirely, claim it's a government conspiracy, a hoax, a misinterpretation. Humans are remarkably good at rejecting information that doesn't fit their existing beliefs. Think about how these reactions would manifest. Financial markets would probably crash initially out of sheer uncertainty. When people don't know how to value the future, they pull back. Religious institutions would scramble to provide theological frameworks. Some would adapt easily. God created them too. Others would struggle more fundamentally. Governments would convene emergency sessions. The United Nations would probably establish a committee to coordinate global response. Scientists would be overwhelmed with requests for information, explanations, predictions. And social media would absolutely explode. Every person with an opinion would share it. Conspiracy theories would flourish. Misinformation would spread faster than accurate information. Third, the strategic questions. Assuming we've confirmed 3i Atlas is artificial, governments would immediately need to address several questions. Should we attempt to communicate with it? And if so, what do we say? This is not a simple question. Dr. Stephen Hawking, before his death, warned against attempting contact with alien civilizations. His reasoning: we don't know their intentions. Broadcasting our presence could be dangerous. Others, like Dr. Seth Shostak at SETI, argue that if they're already here observing us, they know about us. There's no additional risk in attempting communication. We might as well try. But what would we say? Who gets to decide what message represents humanity? In 1977, NASA sent the Voyager Golden Record into space, a record containing sounds and images from Earth, meant to communicate about human civilization to any alien intelligence that might find it. The selection process was led by Carl Sagan and a committee. They included music from various cultures, greetings in multiple languages, sounds from nature, and images of human life. But even that carefully curated message was controversial. Some criticized what was included, what was excluded, who got to decide. Now imagine trying to craft a message in real time, with the whole world watching and everyone having opinions about what should be said. It would be nearly impossible to achieve consensus. Fourth, the long-term implications. But let's think beyond the immediate chaos. What would the world look like 1 year, 10 years, 50 years after confirming that 3i Atlas is artificial? Dr. Catherine Denning, an anthropologist who studies the cultural impact of astrobiology, argues that the long-term effects would be more profound than the immediate shock. She writes, "The confirmation of extraterrestrial intelligence wouldn't just be a news event. It would be a permanent shift in human consciousness. Everything that comes after would be in a post-contact world. Our philosophy, our religion, our sense of identity, all of it would be fundamentally altered. Think about how historical discoveries reshaped human consciousness. When we learned the Earth is round and orbits the sun, it took centuries for that knowledge to fully permeate human thinking. But eventually, it changed everything about how we see ourselves. When we learned about evolution and our connection to other life forms, it fundamentally altered our understanding of human nature. When we developed atomic weapons and gained the power to destroy ourselves, it created an existential awareness that still shapes global politics. The confirmation of alien intelligence would be at least as significant as any of these, possibly more so. It would create what we might call the post-contact era, a fundamentally different phase of human civilization. In the post-contact era, education would change. Every child would grow up knowing that we're not alone, that intelligence exists elsewhere, that we're part of a larger cosmic community, even if we can't yet communicate with it. Science would be revolutionized. If we can study alien technology, even from a distance, we might learn new physics, new engineering principles, new ways of thinking about reality itself. The scientific insights could be transformative. Technology development would accelerate. Just knowing that interstellar travel is possible would inspire massive investment in space technology. Nations would compete to be the first to develop the capabilities to reach or intercept interstellar objects. Philosophy and religion would undergo reformation. New schools of thought would emerge. New religious movements might form around the confirmed existence of alien intelligence. Existing religions would develop new theological frameworks. Global politics might shift. The existence of a them might help create a stronger sense of human unity, a sense of us as humans rather than as divided nations and cultures. Or it might create new divisions between those who want to reach out and those who want to hide. The economy would transform. New industries would emerge around space exploration, astrobiology, and eventually, perhaps, trade or communication with alien civilizations. Old industries would decline as priorities shift. Think of it like this. Imagine if in 1491, Europeans had discovered radio signals from the Americas before physically reaching them. They would have known for certain that other civilizations existed, even if they couldn't yet visit or communicate effectively. How would that knowledge have changed European society? How would it have changed their eventual contact with the Americas? That's approximately where we'd be. Knowing aliens exist, but not yet able to interact with them directly. Fifth, the ethical considerations. But here's where it gets really complex. Knowing aliens exist raises ethical questions we've never had to seriously confront. Do alien intelligences have rights? If we eventually develop the capability to reach 3I Atlas, would it be ethical to capture or dismantle it to study it? Or would that be a violation equivalent to capturing and vivisecting a sapient being? If the probe contains artificial intelligence, does that AI have moral status? Is it a person in any meaningful sense? Can it suffer? Does it have interests we should respect? Dr. Peter Singer, the philosopher known for his work on ethics, addressed this in a 2023 essay. If we encounter intelligence that's clearly sapient capable of suffering, having experiences, holding preferences, then our ethical obligations extend to it, regardless of whether it's biological or artificial, human or alien. The question is how we determine sapience in something utterly unlike us. These aren't abstract philosophical questions. They're practical ethical dilemmas we'd need to answer. And here's the really uncomfortable part. If we conclude that alien probes have moral status and rights, then we might have obligations to them. We might need to protect them. We might even need to help them. Imagine discovering that 3I Atlas is damaged and failing. Do we have an obligation to repair it? To help it complete its mission? What if its mission conflicts with our interests? These questions don't have easy answers. But the confirmation that 3I Atlas is artificial would force us to answer them anyway. And honestly, that might be the best thing that could happen to us. Because confronting these questions would force humanity to think more deeply about consciousness, rights, ethics, and our obligations to other minds. It would force us to grow up. And maybe that's exactly what we need. Now let's talk about something practical. If we wanted to actually study 3I Atlas closely, to definitively determine whether it's natural or artificial, what would that take? Because this isn't just a thought experiment. Real scientists and engineers are seriously considering missions to do exactly this. First, let's understand the challenge. 3I Atlas is moving at approximately 66 kilometers per second relative to the Sun. That's incredibly fast, over 237,000 kilometers per hour. For context, the fastest human-made object ever, the Parker Solar Probe, reached a maximum speed of about 192 kilometers per second. But that was during a close approach to the Sun using gravity assists. Sustained speeds are much lower. To intercept 3I Atlas, we'd need to launch a spacecraft accelerated to match 3I Atlas's incredible speed, navigate precisely to intercept it, slow down enough to study it rather than just flying past. Do all of this before 3I Atlas gets too far from the Sun for effective communication back to Earth. This is an enormous technical challenge. Dr. Andreas Eng, a space engineer who leads the Initiative for Interstellar Studies, has analyzed the requirements. In a 2024 paper, he concluded, an intercept mission to 3I Atlas would require either revolutionary propulsion technology or a mission profile that accepts a very brief flyby at high relative velocity. With current technology, detailed study is almost impossible. But almost impossible isn't the same as completely impossible. Let's look at what could actually be done. Option 1. A flyby mission with current technology. This is the most feasible option in the near term. Launch a spacecraft as quickly as possible, use gravity assists from multiple planets to build up speed, and arrange a trajectory that intersects with 3I Atlas. The European Space Agency actually studied exactly this scenario after Oumuamua was detected. They called it the Comet Interceptor mission. The concept: keep a spacecraft ready in orbit, and when an interstellar object is detected, rapidly redirect it for an intercept. The Comet Interceptor mission is actually being developed, with a planned launch in 2029. But it might be too late for 3I Atlas, which is already receding and might be out of practical reach by then. If we could launch something quickly, within months, we might still catch 3I Atlas, but the flyby would be incredibly brief, maybe just minutes or even seconds in close proximity. The spacecraft would need to gather as much data as possible in that tiny window. Think of it like trying to photograph a bullet in flight. You get one shot. It needs to work perfectly. There's no second chance. Dr. Jim Green, former NASA chief scientist, estimated in a January 2025 interview that a crash program to launch an interceptor could cost $500 million to $1 billion and would require unprecedented cooperation between space agencies. Is it worth it? If there's even a 10% chance that 3I Atlas is artificial, I'd argue absolutely yes. The scientific return would be incalculable. Option 2. Advanced propulsion for a rendezvous mission. Instead of a brief flyby, what if we could actually match velocities with 3I Atlas? Fly alongside it, studying it for extended periods? This requires much more advanced propulsion. Several technologies are being developed that might enable this. Nuclear, electric propulsion, using a nuclear reactor to power an electric propulsion system, providing much higher efficiency than chemical rockets. NASA's been developing this technology for future Mars missions and deep space exploration. Fusion propulsion. If we can achieve controlled fusion, it could provide the power and specific impulse needed for interstellar intercept missions. Still experimental, but progress is being made. If 3I Atlas is artificial, it's evidence that this process has happened elsewhere, that the universe reliably produces intelligence. That consciousness isn't a weird fluke that happened once on Earth, but a natural and perhaps inevitable outcome of physical law. That changes everything about how we should think about ourselves. We're not accidents. We're not meaningless specks. We're nodes in a vast network of intelligence spanning space and time. Dr. Carl Sagan captured this beautifully. The cosmos is within us. We are made of star stuff. We are a way for the universe to know itself. If intelligence is common, if it's spreading throughout the cosmos, if civilizations are sending probes and creating new universes and engineering at scales we can barely imagine, then consciousness is the most important thing in existence. Not matter, not energy, consciousness. And that means your consciousness, your experience, your thoughts, your unique perspective matters cosmically, not just personally. Think about that. Really think about it. You are the universe experiencing itself. And if intelligence is eternal and cosmic, then in some deep sense, you're connected to every other mind that has ever existed or will ever exist. That's not mysticism. That's the logical conclusion of taking seriously the idea that intelligence is a fundamental feature of reality. And 3I Atlas might be our first concrete evidence of it. This is why this matters. This is why we should care. This is why studying a distant, strange object flying through our solar system is one of the most important things we could possibly do. Because it's not just about them. It's about us. About what we are. About what we might become. About the role of consciousness in the cosmos. And that's as profound as it gets. So we've covered a lot. Your mind is probably spinning right now. You're contemplating interstellar probes, cosmic engineering, the nature of intelligence, your place in the universe. Now let's bring it back to something practical. What should you actually do with all this information? Because understanding something is meaningless if it doesn't change how you think or act. First, expand your perspective. Most people live their entire lives focused on immediate concerns. Their job, their relationships, their bills, their daily problems. Those things matter. Of course they do. I'm not suggesting you abandon practical concerns, but context matters too. Zoom out sometimes. When you're stressed about something that seems overwhelmingly important, remember, there might be probes from alien civilizations flying through our solar system right now. There might be billions of intelligent civilizations scattered throughout the cosmos. The universe is vast and ancient and strange. Your problem, whatever it is real and valid. But it's also temporary and local. This isn't about making your concerns seem trivial. It's about gaining perspective that can help you handle those concerns more wisely. Dr. Viktor Frankl, who survived the Holocaust and later became a psychiatrist, wrote about the importance of meaning and perspective in his book, Man's Search for Meaning. He found that people could endure incredible hardship if they could see it as part of a larger story or purpose. Understanding that we might be part of a cosmic community of intelligences is your life story a different context. You're not just living and dying in obscurity. You're part of something bigger, the universe's ongoing process understanding itself. That perspective can be liberating. Second, develop scientific literacy. One of the biggest challenges we face as a civilization is the growing gap between what scientists understand and what the general public understands. This makes us vulnerable to misinformation, conspiracy theories, and poor decision-making. If you've watched this far into this video, you clearly have curiosity about scientific topics. Nurture that. Develop it. You don't need to become an astrophysicist, but you should understand the basics of how science works, how evidence is evaluated, why peer review matters, what makes a theory scientific versus pseudoscientific, how probability and statistics work, why experts disagree, and how scientific consensus emerges. These skills, scientific literacy, are crucial not just for understanding 3I Atlas, but for navigating an increasingly complex world. When the next pandemic comes, or the next climate debate, or the next technological disruption, you'll be better equipped to evaluate claims and make informed decisions. Dr. Carl Sagan warned about this in his 1995 book, The Demon-Haunted World. We've arranged a global civilization in which most crucial elements profoundly depend on science and technology. We have also arranged things so that almost no one understands science and technology. This is a prescription for disaster. Don't be part of the problem. Be part of the solution. Read, learn, ask questions, challenge your own assumptions. Third, support space exploration and scientific research. Here's a hard truth. Governments fund what citizens care about. If you want missions to study interstellar objects, if you want better telescopes, if you want more astrobiology research, you need to make your voice heard. This means contact your representatives and tell them you support space exploration funding. Support organizations like the Planetary Society, SETI Institute, and others doing this work. When space agency budgets are debated, pay attention and speak up. Share science content and help others understand why this matters. Individual actions do matter. Politicians respond to constituent pressure. When enough people care about something, policy changes. Fourth, Think long-term. If there's one lesson from the possibility of interstellar probes, it's that truly advanced civilizations think in timescales of thousands or millions of years. We need to develop that capacity too. This means caring about climate change and environmental sustainability, AI safety, and ensuring technology benefits humanity long-term. Space colonization as insurance against existential risks. Preservation of knowledge and culture. Building institutions that can last centuries. Raising children who are wiser and more capable than we are. Dr. Ramon Krenznerek, a philosopher who studies long-term thinking, argues that most human problems stem from short-term thinking. We sacrifice the future for immediate gratification, but we don't have to. We can choose differently. Every time you make a decision, ask yourself, am I thinking about just today, or am I thinking about the world my grandchildren will inherit? That shift in perspective can change everything. Fifth, cultivate wonder. In our modern world, it's easy to become cynical, to think you've seen everything, to lose your sense of amazement at existence. But look, right now, as you watch this, there's an object from another star system flying through our solar system. The light you see from stars at night has traveled for years or centuries or millennia to reach your eyes. The atoms in your body were forged in the hearts of dying stars billions of years ago. This is all true, all real, all happening. And it's absolutely astonishing. Don't lose that sense of wonder. It's one of the most valuable things you have. Dr. Rachel Carson, a marine biologist who helped spark the environmental movement, wrote, "Those who contemplate the beauty of the earth find reserves of strength that will endure as long as life lasts." There is something infinitely healing in the repeated refrains of nature, the assurance that dawn comes after night and spring after winter. Wonder isn't just emotional indulgence. It's fuel. It motivates you to learn more, do more, be more. Cultivate it. Protect it. Share it. Sixth, be humble but not insignificant. Here's a delicate balance. You should be humble about how much you don't know, how vast the universe is, how young and limited our civilization is. But you shouldn't conclude from that humility that you're insignificant. You matter. Your choices matter. Your consciousness matters. The universe is unimaginably large, but consciousness is unimaginably rare and precious. The fact that you exist, that you can understand these ideas, that you can make choices about what to do with your life, that's miraculous.